Hello everyone, and welcome to the lesson where we learn about the sine and the cosine functions, how to graph them, how to identify their domain and range. Okay, these are really important functions when you move into waves and cyclical functions, springs, and harmonic motion. So today we're going to talk about how do we graph them, what are the important points. So we're going to start with some review of the unit circle. Okay, and these two problems. Okay, I give you an angle, and I want you to find the coordinates. Find the x and the y coordinates. Go ahead, pause the video. I want you to do it without a calculator, and I want the exact answers, so you should have no decimals. So on number 11, we have a second quadrant angle, which means the x-coordinate is negative and the y is positive. And we remember our special right triangles and determine is the x bigger, the y bigger, or are they the same. So this triangle has the small x and the big y. This triangle has the 7 pi over 4 angle over here. So the base and the height are the same because this will be the isosceles right triangle. And in the right example, the y is negative. So we're going to use these ideas today to graph the sine and the cosine function. We remember that sine is the y value and cosine is the x value. And sometimes cosine could be negative if it's in the second or third quadrant, and sine could be negative if it's in the third or fourth quadrant. And we're going to graph the action for sine of how the height changes as we spin around the circle. So the sine and cosine functions are cyclical functions. They're period functions that represent what's happening to the sine of an angle as we spin around the full circle. And cosine, which I have spelled wrong here, same idea. Cosine is what's happening to the x-coordinate as we spin around the circle. Now we've talked also about domain and range, and this function is going to have a certain domain and range. Domain would be what x values work, what are the inputs that I can have, and then the range is what are the outputs, what are the y values that work. We're going to do some exploring, and then we're going to get to our graphs. So first off, what's the largest value and the smallest value you can get from the sine of an angle? What are the extremes? So you may be thinking and saying, okay, sine is the height, so where is the height the biggest? And it's the maximum height you can get is 1 at the top of the unit circle at pi over 2 radians. So sine of pi over 2 is 1. And then the minimum is at the very bottom, so the minimum is negative 1 at 3 pi over 2. So we know the sine of at least 2 angles already. We know the sines of a whole lot more, but we have the maximum and the minimum heights. Now we got to do some more exploring. What do we already know about sine function? Okay, what do you know about sine? And what are some of the angles that you know the sine value of? Think about it. Write some down from your unit circle. Make connections. What do you know about the sine function? Take a few seconds. Pause the video if you'd like. Okay, so some ideas I've seen. Sine is the height function. It's the y-coordinate of the unit circle. It's the opposite over the hypotenuse. So if we can visualize the unit circle as we go around it, is the height increasing or is the height decreasing? Is the height positive or is the height negative? And then I'm going to list some of the sine values. I'm going to list the ones where it's 0, 1, and negative 1, because those are going to help me when I graph the sine function. Okay, at 0 radians, I have a height of 0. Then I go a quarter turn, so I wind up at the top of the unit circle. At pi over 2 radians, I have a height of 1. And then I go back to pi radians, which is on the left side of my unit circle, and I have a height of 0. Then I dip into the negatives, and then I go back to 0 again, once I made my full circle. So I'm going to use these points to graph. So the sine function is going to be the relationship between the angle, which we're going to deal with in radians, and then the sine of that angle. So the x-axis is going to be the angle measurement in radians. So we're going to have to put some radian measurements on our x-axis. And then the y-axis is going to be the output, the sine value. And we're going to look at which points are really important to graph and how we get this curve completely on our graph. Now you're going to need graph paper for this. We're going to have to be careful with how we scale our axes. So to graph the sine function, I like to say we need 5 points. Okay, we need to make one full cycle. We need to ask ourselves, what's the domain? What's the range? How high does it go? How low does it go? What are important points? And how long does it take the function to repeat or to go around the circle once? So I know I can find the sine of any angle around the full circle from 0 to 2 pi. So my graph's going to go all the way to the left and all the way to the right. The range, however, we said the minimum is -1 and the maximum is 1. So the range is going to go from -1 to 1. So our graph, okay, our maximum height is going to be 1 and our minimum height is -1. And we know that it's at -1 okay, at 3 pi over 2. So 3 pi over 2 has a height of -1. And at pi over 2, it has a height of +1. And then the full circle is 2 pi, so it's going to repeat every 2 pi radians. We're going to more or less copy and paste the function every 2 pi. It's going to look the same. It's going to do a full wave and then do another full wave. We're generally just going to graph 1, maybe 2 cycles. So this is how we do it. Okay, we need to graph 5 points. Okay, I labeled my axis with pi over 2, pi, 3 pi over 2, and 2 pi. And then I also went backwards, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And I spaced it out a little bit so I have some space to work with. I'm also going to put a 1 up here and a -1 down here. Okay, I'm going to say my scale is every 4 I go up, I count that as 1. So we said at 0 radians, the height is 0. Pi over 2, think of the y-coordinate at pi over 2. Okay, pi over 2, we got a max height. And then we keep spinning around the circle and figuring out where we are. So at pi, we're at 0, and 3 pi over 2, we're at the bottom, and then 2 pi, we're back in the middle. And we can go backwards. So negative pi over 2 is at the bottom of the circle, and then pi is back at the middle, and negative 3 pi over 2 is at the top, and negative 2 pi is at the starting point again. And we put a nice smooth curve through it. Now, I'm not an art major, and several of you are not art majors, but we put a curve through it, not a straight line. Do not play connect the dots where we connect everything with straight. And we should put arrows at the end to make it the sine curve. It's not the sine line, it's the sine wave. So that's 2 cycles. So from 0 to 2 pi, we have 1 cycle. From negative 2 pi to 0, we have a cycle. And a cycle goes from middle to middle, or crest to crest, or trough to trough, as long as we get one full view of everything happening. So that's what the sine function looks like via computer. Much prettier, much smoother curve. Still goes 0 to 2 pi, middle, then the high, then the middle, then the low, and then the middle. Because we're dealing with where are we on the unit circle? What is the y coordinate? What is the height? The opposite side line. Now the same thing is true about the cosine function. The graphs are near identical. The x-axis is still the angle measurement. The y value is now just the cosine measure. So this is going to be an interesting concept where the y coordinate is really the x part of the unit circle. So we got to think about it. We're going to graph cosine the same way as we graphed sine. What angles can we put in? We can put them, all of them in. The range, okay, still -1 to 1. It's just in different spots. Okay, the maximum cosine is at cosine of 0 radians. So in this case, we have the point 0, 1. Because 0 is my angle, 1 is my output. And then at pi, on the left side, I have the smallest x coordinate. So I have pi -1. So I'm going to go find those points. This also deals with that same circle, so it's going to repeat every 2 pi. So I'm going to be able to graph a few cycles of it. So here we go. We're going to visualize our unit circle, think about it. We talked about at 0 radians, our x value, okay, at 0 radians, our x value on the unit circle is 1. Then at pi over 2, at the top of the unit circle, our x coordinate is 0. Then at pi, then at 3 pi over 2, and at 2 pi, we repeat. And I like to think of it as high, middle, low, middle, high, and cycles back, middle, low. I can do as many cycles as I want. Generally, I like to graph at least one cycle, a lot of times two, put the curve through it. Once again, curve's not going to look wonderful, but it's got to look like a curve. Now, the cosine function should not go above 1. So this spot I have in the top left, I'm going to erase it because that's inaccurate. Now I'll just connect because after it hits the top, it's got to go down again. It doesn't go up above the top. That doesn't make any sense. So this is the cosine curve, very similar to the sine curve. It's just cosine starts at the top. Cosine starts at the top. Sine starts at the middle and goes up. You think of it as a Ferris wheel, sine function like a Ferris wheel. You get on here and you go up and down and up. Cosine would be a weird Ferris wheel where you get on at the top and then you go underground, you go down and underneath. And but think of the unit circle when you're graphing these. You'll be able to do it. And once again, much prettier picture of the cosine function. They didn't even label this as pi over 2. They just went pi, and 2 pi, and 3 pi. And in the middle, we need to know that's pi over 2 and 3 pi over 2. So, questions to check to see if you understood how to graph these. How long does it take to complete one cycle of sine? What's the domain of the cosine and what's the range of the cosine? Pause the video. Show yourself you can do these. And then we'll check the answers. So it takes 2 pi. Okay, we call the period is how long it takes to do one rotation, one cycle. So the period is 2 pi because once around the circle is 2 pi radians. The domain is all real numbers. I could put anything in for x. I could put any angle in here. put a fractional, I put a whole number, I put decimal, positive or negative, anything goes in here. And then the range, the lowest number I can get is -1. I get as high as 1, I get all the values in between. This is the sine and the cosine function. In future classes, you're going to learn how to move this graph up and down and left and right and make it wider and narrower. But now you have the basics of sine and cosine.